In this example, we're going to look at sample size and margin of error. Complete the table below by computing the sample size for each of the given margin of errors. Round to the nearest whole number. Okay. So we did a problem like this where we were given the sample size and we found the margin of error. In this case, we're going to do the reverse. Our conservative estimate, if we solve the margin of error formula for the sample size, we get that the sample size equals 1 over the square of the margin of error. And also note that when we put this in the formula, we need to write the margin of error as a decimal. So let's look at the first one. If we want a margin of error of 1%, the sample size will need to be 1 over 1% as a decimal is 0.01, and we need to square that. Okay. Again, I'm going to compute the denominator first, and then I'm going to use the reciprocal button. So 0.01 squared. Hit this button to reciprocate it, and we get that we need a sample size of 10,000 to have a margin of error of 1%. Let's look at 2%. The required sample size would be 1 over 0.02 squared. So we will take 0.02 and square it, reciprocate the result, and we have 2,500. For 3%, we'd have n equals 1 over 0.03 squared. So we will take 0.03, square it, reciprocate, and we'll round to the nearest whole number, which is 1,111. And finally, with 4%, 1 over 0.04 squared. And we'll take 0.04 and square it, reciprocate the result, and we have 625. Okay. And now let's look at some patterns. So we practice. Notice as the margin of error increases, the sample size decreases. Okay. So as we have less precision, because remember larger margin of errors have less precision than smaller ones, you need a less small sample size. So as the margin of error increases, so moving down in the margin of error column, we see they increase. The sample size, and if we look down this column, decreases. And then we're asked, does doubling the margin of error split the sample size in half? Okay, so let's look at the difference between 1% and 2%. So these aren't all doubling here. It's not 1, 2, 4, 8, but 2% is double 1%. Okay, and let's actually find a ratio here. So you can see this is not half. 2,500 is not half of 10,000, but let's find the ratio and write it as a decimal. And you may know what this is, but we'll do it on the calculator anyway. And we get 0.25. So in this case, doubling the margin of error, we needed a quarter of the sample size. We can also compare 2% and 4%. So let's look at these two. So what if we had, because 4% is double 2%, that's why I chose that. So, whoops, I wrote that in the wrong direction. If we can see that 625 is not half of 2,500, but let's see what percent or fraction it is. So 625 divided by 2,500, and notice we get 0.25 or 1/4 again. So these are both 1/4. Okay, so doubling the margin of error actually decreases the sample size by 1/4. And I'm not going to do it here, but you can compute this algebraically if you enjoy algebra and you like a fun problem. Okay, so doubling the margin of error, it does not split the sample size in half. Okay, so the answer is no. We could say that it splits it into a quarter, but we'll just leave this general result. The important idea here is that these are not proportional in the sense that doubling in one direction gives you the same doubling in the other direction.